Thank you. Good afternoon, everyone. Thank you for the invitation to speak today. I believe my slides are about to appear on the screen. There we go. I wanted to take a very economics-based approach, one which is possibly an oversimplification. People often say that price and quantity are the only two concepts that economists can keep in their minds at the same time. So we're going to use those tools and try to approach what was described by the previous two speakers in a different way. We're going to be starting, of course, from the pressures relating to climate change, which are weighing on aviation as an industry. I will be dividing my presentation into three parts. First of all, what we economists describe as the iron law of coupling, which says that you can't stop the volume of traffic from increasing in step with economic growth, which makes it so important to slow down growth, according to some, because precisely of this coupling law. Secondly, I'll be talking about the microeconomic basis of coupling, which has a lot to do with purchasing power and the value ascribed to time. And then we will return to the challenge for climate change in light of this. So if we move to the next slide, we can see a representation which students will no doubt appreciate. They'll be reminded of log-log graphic representations. So you can see that you have per capita traffic volume on the vertical axis and GDP on the horizontal axis. So the horizontal axis starts in the 1960s and the vertical one is in kilometers. On the very top, in light blue, you can see where the United States stand with rough equivalents between $1 and 1 kilometer, in the sense that as GDP per capita approaches $20,000, the figure in kilometers reaches about 20,000. Similarly. So a very strong correlation, as you can see here, between GDP and distance, but it's also about a link between GDP and speed, because the time spent in travel continues to be about 1 hour a day on average. So that, if you're able to cover more miles or kilometers than you used to, this is often simply because the GDP per capita in your country is increasing. The richer you become, the fonder of speed you get. And that is represented in this chart, where you can see the case of the United States for essentially most of the 20th century. We can see in black at the top the average distance covered every day. This is a log scale, a log on the vertical axis. And you can see in the early days we were at about 4 kilometers in 1880 per day, which were covered walking or possibly on horseback. And in the late years of the 20th century, we were at a level that approached something like 60 kilometers per day, if the interpreter heard correctly, which was covered, as you can see here, in cars, buses, motorcycles, but primarily a lot of the kilometers were covered on aircraft. And that puts an additional slant on what we were hearing from Stefan Gosling. We can see also that the faster modes of transport have been superseding slower ones. Initially, cars took over, but they themselves were replaced by planes, which also replaced trains in the US. And it's interesting to see that trains had an upward blip at one point when there was some rationing for car fuel, as you can see, which were dipping at the time during the Second World War. François Gémen was describing earlier the idea of the possibility of moving towards rationing. So slide 3 I took from my colleague François Bourguignon, and he started from data taken from the Civil Aviation Authority, 1970-2013. Again, he used a log-log representation here. So you have GDP on the horizontal axis in purchasing power parities at constant income. And you can see on the vertical axis the distance covered. This highlights differences between different countries. You can see on the top right high-income OECD countries where the elasticity is very marked. But in fact, this elasticity is the same for low-income countries. They're all aligned with a very good R2, as we could say, an elasticity which is 1.36. Every time GDP goes up roughly 1%, similarly, the distance covered will increase by 1.36. And that is quite a problem, because it means that if the world continues to get richer, as it has been doing over the past 30 years, then air traffic will be growing even faster, as if there could be no end to this pattern. So we need to think about the sources of this limitless character of the patterns observed. And that's what we're going to look at here, trying to connect macroeconomics with microeconomics. And we can pull up all 3 bullet points straight away. There we go. The fundamental idea in microeconomic terms is that when your income increases, basically you will prefer diversity, variety, rather than to spend every weekend at your parents or at your cousins who live 5 kilometers away. If it's possible, accessible for you once or twice a year to spend a weekend, say, in Rome or Barcelona, you will be tempted to do that. And if your purchasing power increases and the added speed of planes enables you to cover a much greater distance in the same travel time, you have everything assembled for the mechanics of the development of tourism travel. It's cheaper, it's faster, and it enables you to travel quite far away, quite frequently, for short trips. So you can see on the next slide the foundations of the problem, but also potentially the solution, namely the incredible, phenomenal drop in the cost of travel, expressed here in numbers of working hours for someone on minimum wage in France. As you can see, so back in 1980 then, to fly to Singapore from France, you had to work at minimum wage for about 730 hours. And to make the same trip in 2020, well, to be exact, at the end of 2019, you only had to work, let's say, roughly 10 times less. About 2 weeks of work was enough, roughly speaking, to buy a ticket to Singapore. And you can see similar patterns for New York, Tunis, Athens, although the drop has been a little bit less marked. There has been a very steep decrease in the time worked to buy a ticket to go there. So that the time value and working hours of air travel has changed very markedly. Of course, you could argue similarly about car travel. Today, with 1 hour at minimum wage, you can buy 6 to 7 liters of gas, whereas before the oil shock, you could only buy about 3 liters, and so that you can cover 4 times the distance now by car. However, if you opt for a plane, you can go anywhere between 5 and 10 times further for the same price, the same number of working hours. So This is what I describe as economic speed in the rest of my presentation. And as you can see here, ever since Ivan Illich, we've been talking about the notion of generalized speed, which holds that if you want to move around, you have to spend time in transport, so that what counts is how long it takes to get from door to door, the door-to-door speed. Now, we're talking about tourism here, not commuting in an urban setting. If you take your car for a long distance, with a speed of 60 kilometers per hour, if you take the train, it may be about 100 kilometers per hour if you factor in getting to the station and getting to destination at the other end. And similarly, for air travel, it would be approximately 250 kilometers per hour. That's the physical door-to-door speed. Next, you have what I was describing just now, the economic speed. Let's say you're on minimum wage, you make 10 euros roughly an hour. Since the cost per kilometer for air travel is about 5 cents per kilometer, so you can buy some 200 kilometers with that 1 hour, those 10 euros you earned in an hour of work. With rail, which is 10 cents per kilometer, you can reach an economic speed of 100 kilometers per hour, and at 25 cents, 40 in a car. So this is a special kind of average which takes into account the time that you spent on traveling, as well as the characteristics of the trip itself. That would be the generalized speed in the third case, a kind of harmonized average. And you can see that in those terms, air travel enables you to travel 4 times as fast in terms of generalized speed as going by car. And this highlights the attractiveness of taking a plane, even with a relatively modest income, perhaps not every week, perhaps not every month, but once or twice a year. And it's a lot more preoccupying if you're earning 3 or 4 times the minimum wage, because then your economic speed will be 3 or 4 times that of the minimum wage worker, so that with 1 hour of work, you can purchase a trip by plane, 600 kilometers, rail, 200 kilometers, or car, 120 kilometers. And that highlights the tremendous development potential of air travel, which is accessible to anyone at a generalized cost, which is much lower than other kinds of transport. And so you can see the leverage effect on potential changes as the different parameters move around. And what we see here is what has happened in France since the 1990s. You can see on the left-hand scale the distances covered by car. There is a peak in car traffic, where we were at about 11,000 kilometers per person per year. We're at about 10,000 currently. In green, you have rail travel, and that's on the right-hand scale. We were at about 800 or 900 kilometers per year, despite the development of high-speed trains in France, the so-called TGV. We're still at about 1,100 or 1,200 kilometers per year. And finally, in blue, you can see that we've reached some 2,500 kilometers per year in airplanes. That includes international flights. If I were to take only domestic flights along the lines described by François Gémen earlier, that we would be talking about 200 kilometers per person per year. And again, this is on average, since a lot of people simply don't take planes. So you have peak moments in car transport, in rail transport, where things reach a high point and then start to plateau. More and more people, instead of acting according to what economists would say, you choose your destination first and then your mode of transport, have been taking things the other way around, choosing the mode of transport first, going to a low-cost company, and then deciding where to go on the basis of what was on offer. And that brings us to the next slide. The idea that, as we saw, there is this massive potential demand for air transport. Let's pull up all the bullet points here. So because of that very substantial potential associated with the physical speed, but more importantly, the economic speed of air travel. And it's important to understand that airplanes have been very good at taking advantage of deregulation in Europe. They've been able to make the utmost of competition to lower prices. They've also been able to greatly increase the numbers of actual passenger seats occupied on planes through low-cost offerings. And there have been tremendous inroads made in the engines of airplanes. All of this has conspired to produce the same result, namely huge growth in air travel because of the performance levels achieved. And flight shaming is something which potentially is affecting a very high-performance student, the best performer in the class among the different players in transport because of the various factors that I just described. However, there has been no increase when it comes to the dependency on fossil fuels.
So on this next one here, if we can show all items again. Now, if I'm trying to regulate all that, well, you can regulate via prices because economists are fond of such types of regulation. What I changed in the table at the bottom is the price of air transport. Instead of setting it at 5 centimeters per kilometer, 5 cents per kilometers, I've added 1.4 cents. Why? Because that's exactly the evaluation made by the European Handbook on External Costs, saying that for a Paris to New York flight on an Airbus A340, the cost is 1.4 euro cents. If you apply a value per ton of CO2 of 100 euros, it's a lot because that's 4 times the current price of a ton of CO2 on the market. So if you do that, of course, the economic speed drops, but for a minimum wage workers, it's still 156 kilometers per hour, so 50% above real and 3 times more than the car, and so the generalized speed is still 4 times higher for the plane in spite of this tax of 100 euros per ton of CO2. So if we move on to the next one to take it a bit further, what have we done? If you can show the next 2 items, if you take someone who earns 3 times minimum wage and you apply this tax of 100 euros per ton of CO2, well, the speed, which was 600 kilometers, drops to 468 kilometers per hour. So the impact is relatively limited for this population. And even though you apply an extremely high value, so 300 euros per ton of CO2, in that case, you need to add 3 times 1.4 cents, so you get 9.2 cents per kilometer, and you still have an economic speed of 26 kilometers per hour for a person who makes 3 times minimum wage. But if you divide it by 3, that's 109 kilometers per hour for a minimum wage worker, so much higher than car and rail. And if you take the generalized speed, if you take the harmonic average, harmonic mean, you get 75 kilometers per hour. So if you do these quick maths, the potential attractiveness of flying remains very high, even if you had carbon taxes in place. And that's why on the next slide, you may be looking at other constraints, those that were discussed earlier by François Gemène. Since you can't put constraints on prices, prices are not sufficient, you need to restrict quantities. That's what the London School says in terms of the environment. And so to restrict quantities, you can put quotas in place, but much more limiting than what was put in place in Europe so far with the ETS. Since now the price of CO2 is the reason why it's so low on the CO2 market is because there are too many quotas. So quotas should be cut massively to drive prices back up to 100 euros or 2 or maybe 300 euros per ton of CO2. That was discussed earlier. You can see that if these quotas are sold and bought on a secondary market, if you get a secondary market of tradable quotas, well, the ability to pay of the richest people will remain very high, and they'll be able to fly. Not, as François Gémen said earlier, well, saying that I'll fly with hydrogen and I'll let the poor fly with kerosene, but the poor will no longer be able to fly, but rich people will still, because they are able to pay. And so now there are arguments for tradable permits. Well, not for tradable permits, but for non-tradable permits that cannot be resold. And so François Gémen mentioned it earlier. People are dreaming of planned and administered economies, but you may wonder about the conditions of granting this permits to this or that person. So now when some climate gurus are talking about negative growth, ungrowth, they say that this is inevitable. They say, well, when they say that ungrowth is inevitable, there will be very stringent rationing on quantities without a secondary market, so that the wealth cannot really come out stronger. And that's exactly what happened with the lockdown. In a way, that was a joke of history, because played on us by history, because the pandemic showed that we had to learn how to live with very limited amounts of rights to travel. So the last slide now, you can see that as an economist, I tend to turn the underlying formula around that you could find in the title of the presentation. Air transport is currently challenged by climate commitments, but given the huge potential demand for air transport, I'm wondering whether climate commitments are going to be challenged by the development of air transport. So thank you. Thank you, Yves Crozet, for this very thought-provoking analysis. I don't know whether this is something we should dream about, a sort of constant pandemic. That might be a very theoretical solution to the decline in the number of flights, or at least a restriction on the number of air flights. I think that that's yet one added reason for us to beef up our actions in terms of decarbonization, or at least one reason to go that route.